I will start with introduction, which is background of study. So the oil and gas extraction industry involves activities such as exploration, drilling, production, maintenance, and transportation. So during this process, workers are exposed to various hazards including physical, chemical, economic, and psychological hazards. So one of the most significant chemical hazard is benzene, which is naturally found in crude oil and petroleum products. So benzene is classified as Group 1 carcinogen by the International Agency for Research on Cancer, meaning it can lead to cancer in humans. So oil and gas extraction is one of the world's largest industrial sectors, involving activities such as exploration, drilling, production, refining, and transportation of hydrocarbons. So crude oil is a naturally occurring mixture of hydrocarbon that contains a group of chemicals known as BTEX, which stand for benzene, toluene, ethylbenzene, and xylene. So these BTEX compounds are toxic, and long-term exposure can cause serious health effects, including color vision impairment and chronic neurological problems. So due to their high volatility, these chemicals easily evaporate and are widely present in many oil and gas industrial process. So workers may be exposed to benzene during drilling operation, crude oil handling, pipeline maintenance, tank cleaning, and refining activities. Exposure mainly happen through inhalation of vapors, skin contact with contaminated liquids, or absorption from contaminated surface. So benzene, which is a major component of crude oil and petroleum products, is classified as a Group 1 human carcinogen by the International Agency for Research on Cancer, or IARC. So this classification is based on research and evidence from human studies showing that benzene can cause cancer. Therefore, due to its high toxicity and widespread use, benzene exposure represents one of the most significant occupational health hazards in the oil and gas industry. So now I will explain the basic operation flow benzene exposure. So this slide shows the basic operation flow in the oil and gas extraction process where benzene exposure may happen. So the process starts with exploration and drilling, where crude oil and natural gas are brought to the surface. So during this stage, benzene vapor may be released from drilling fluids and hydrocarbons. Next is production and separation, where oil, gas, and water are separated. So benzene exposure can occur when hydrocarbons are handled or transferred between systems. So the process continues with storage and transfer, such as storing crude oil in tanks and transferring it to the pipelines. So opening tanks and handling hydrocarbons can release benzene vapor into the air. So maintenance activities also pose a high risk, especially when workers enter confined or poorly ventilated areas such as tanks or pipelines. And finally, during the transportation of crude oil, workers may be exposed to benzene through leaks, spills, or vapor release. So overall, benzene exposure mainly occurs during tank opening, hydrocarbon handling, and works in poorly ventilated areas, which makes this activity high risk and require proper control measures. And finally, during the transportation of crude oil, workers may be exposed to benzene through leaks, spills, or vapor release. So overall, benzene exposure mainly occurs during tank opening, hydrocarbon handling, and works in poorly ventilated areas, which makes this activity high risk and require proper control measures.
So I have to present to you guys about health effect of benzene. We have two effects. We have short-term and long-term effect. We have for short-term effect, we have dizziness, headache, eye and respiratory. For long-term effect, we have leukemia, anemia, bone marrow suppression, and central nervous system. So next slide is 2.2.1 industry fatality trends. In this slide, we have figure 4 is occupational fatality rate and oil and gas extraction 1993 to 2010. I got from Wilter at 2014. So the explanation for the graph is the graph shows that fatality rates peak between 2004 and 2008, coinciding with high peak counts during that period. So this indicates that during intense drilling activity, workers are at greater risk due to increased operational pressure, insufficient training, and higher exposure to hazardous tasks. A sharp decline in 2009 corresponded with the economic downturn, which reduced the number of active risks and subsequently fatality exposure. Next slide is hazard identification, risk assessment, and control process. This section explains how hazard in oil and gas extraction activity systematically identified, assessed, and controlled to reduce occupational risk, particularly benzene exposure. For hazard identification is the first and most important step in the HIRAC process. In oil and gas extraction, hazard arise from chemical substance like benzene, hydrocarbons, and solvents. For physical sources like noise, heat, machinery, and vehicles. Third, for ergonomic factor like manual lifting, upward posture. Beside that, confined and poorly ventilated spaces. Benzene is identified as a major hazard due to its volatility and carcinogenic effect. For hazard identification, we have three. First, we have chemical hazard like benzene exposure. Example is inhalation and skin contact. Second, we have physical hazard. Example is noise, heat, fire, explosion, and machinery. Third, biological hazard. Example for biological hazard, bacteria and fungi from contaminated areas. Beside that, we have ergonomic hazard like manual lifting, awkward posture. Second, psychological hazard. Example like psychological hazard, we have stress, fatigue, and long working hour.
This slide represents the HIRAC risk assessment using a risk matrix, which is an important tool in identifying and managing workplace hazards. HIRAC stands for Hazard Identification, Risk Assessment, and Risk Control, and it helps ensure the potential risks are evaluated in a systematic and structured manner. For instance, benzene exposure is classified as a high-risk hazard due to its extremely serious health effects, including long-term organ damage, chronic illness, and an increased risk of cancer. Even if the likelihood of exposure is not the highest, the severity remains very high, which results in a high overall risk rating. In addition, activities such as sand handling that generate silica dust, vehicle operation involving moving machinery, diesel engine emission, and drilling machinery noise are also identified as high-risk hazards. These activities can lead to respiratory disease, physical injuries, hearing loss, or long-term health complications if not properly controlled. Therefore, hazards that fall into the high-risk category clearly indicate the need for immediate and effective risk control measures to protect workers' health and safety. Based on the risk assessment, we proceed to risk mitigation, focusing on step 4 of the risk management process, which is treat the risk. To ensure effective control of high-risk hazards, we apply the hierarchy of control, starting from the most effective measures. First is elimination, where the hazard is completely removed from the workplace. If elimination is not feasible, substitution is applied by replacing hazardous substance such as benzene with a safer alternative. When these options are not possible, engineering controls are implemented, including ventilation system, enclosed process, and machine guards. This is followed by administrative control, such as worker training, standard operating procedures, exposure monitoring, and job rotation. Finally, personal protective equipment, or PPE, is used as the last line of defense to minimize worker exposure. In conclusion, by applying the hierarchy of control, high-risk hazard identified in the HIRAC risk matrix can be effectively managed to ensure a safer and healthier workplace.
In terms of hierarchy of control, the first step is elimination. Benzene-related processes should be removed where possible to completely eliminate the hazard. Next is substitution, where benzene and high-risk chemicals are replaced with safer or low-benzene alternatives. Then, engineering control should be applied, such as installing proper ventilation system and using closed sampling system to prevent benzene release. After that, administrative control are important. These include clear SOPs, safety training, job rotation, and restricting access to high exposure areas. Finally, personal protective equipment or PPE must be used. Workers should wear respirators, gloves, and protective clothing when handling benzene. By applying all levels of hierarchy of control, benzene exposure can be effectively reduced. Overall, oil and gas workers are exposed to many workplace hazards. Among all hazards, benzene exposure is the most serious because it can cause long-term health effects. High-risk activities include tank gogging, sand handling, and maintenance work in confined or poorly ventilated areas. Hierarch analysis shows that benzene exposure often occurs together with other hazards such as noise, heat, ergonomic strain, and psychological stress. Therefore, proper hazard identification, risk assessment, and applying the hierarchy of control are very important. A strong safety culture and compliance with OSHA, NIOSH, and DOSH Malaysia can help improve long-term safety performance. To reduce benzene exposure, several recommendations are suggested. First, engineering control should be improved, such as better ventilation system and closed sampling system. Second, administrative control must be strengthened by implementing clear SOPs, regular safety training, and job rotation to reduce exposure time. Third, substitution should be applied by replacing benzene and high-risk chemicals with safer alternatives. Workers must also use proper personal protective equipment such as respirator gloves and protective clothing. Finally, promoting a strong safety culture through toolbox meeting, effective communication, and hazard reporting is essential.